you so much, and like giving it to Avinash. Off to you, Avinash.
Thank you, Paras. Thank you, Paras. So, thank you for waiting and apologies for the delay, class. And we'll start with another session. This is for basics of blockchain technology. I'm not sure how many of you have. I hope the screen is visible. If there is any issue, any doubt, feel free to interrupt in between. At the moment, I believe that the screen is visible to everyone. And this is the session on the basics of blockchain. Uh, those who have some exposure to blockchain may understand a little more, but do not think that those who do not have any exposure to the blockchain technology, they will not understand the session. So this session is for the
Yeah,
absolute
Avinash,
beginners.
it's not visible.
Yes, it's not visible. Okay,
Sir,
give me a sec.
I'm not able to chat. My
You're
chat
not
box is the
your
administrator is
chat box.
disabled. Yeah.
I'll get on that. I'll fix the chat. By that time, you can continue.
No, the screen
Okay,
is not visible. I can see only people's name. Yeah, now it's
Yeah.
visible. Thank you.
visible. Okay,
Now
I
it's
just
visible.
made the entire desktop visible. Okay, great. So now it's visible to everyone. So as I was mentioning that this is a basics blockchain session, and we'll talk about the technology, we'll talk about the basic details of how it evolved, what is in it for developers or people who want to make a career in blockchain, and how can blockchains be useful to current business requirements. So that's the topic of the discussion. We'll not delve into too much technical details, but you would know enough and you'll be shared material and you'll be given guidance in this session, so how to go through that material. So by the end of the session, if you want, you can you'll be in a position to do a basic blockchain setting for Ethereum. Okay, so that's the agenda. Well, let me take you to the formal agenda page. So we'll start with the introduction. Then we'll talk about any blockchain session doesn't go without talking about Bitcoin. So we'll talk a little about Bitcoin, how it all started, and then we'll go to the next blockchain. It could be the next, it's like the blockchain 2.0 kind of a thing. So Ethereum, which comes with several other abilities apart from the basic blockchain, especially we talk we in common knowledge we call it smart contracts, and I'll be defining them, what are they and how can any business logic can be transformed to a smart contract and run on a Ethereum kind of blockchain. Then we'll talk about the programming language Solidity, which is used to program Ethereum blockchains. We'll also talk at a high level about how Azure platform can be used for blockchain, the blockchain development kit on the Microsoft Azure platform, how this could be utilized and which will ease the pain of complete development and what all services are there. So that's in the agenda today. Okay, this link is for you can fill up the survey, tell about how the session was, or raise your doubts or ask questions. So you should always go ahead and fill this survey. That will help us improve. Okay, we'll start with this video, so please pay attention. I hope it is audible to everyone. Is it? Is the music audible?
You'll have to enable it from the top.
From the top.
Like if you go on the center top, take your cursor on the center top, it'll show a drop down for the teams.
No, no. So I just played the video. Were you able to hear that? That's the question.
No, we weren't.
No, you weren't. Okay, let me just check. Show presenter view. Okay, I'll just play it. If the voice is not audible, then what we'll do is I'll share the link. I'll just play the video.
Avinash is not audible at all.
So is the voice not audible at all?
No, Avinash.
No. Okay. What I'll do is I'll share the link. I'm not sure why it is not audible. It should have been audible. Let me just. Are okay. Okay. What I'll do is I'll share the link of the video. It is anyways available. So I'll share this link and you guys can watch it again. I'll tell you the gist of the video. Okay. So what this video is talking about is uh, it talks about the uh, pros of using a blockchain over any other let's say payment gateway or any other payment network. So the most important is here in this video they show that human beings are dealing with aliens for in order to execute a transaction, and they are preferring they prefer, even the aliens as well as the human beings, they prefer to use blockchain for that transaction. The reason being the humans do not trust aliens, and aliens do not trust us. And blockchain, while using this technology, you may not know or you may not have a belief or a trust on the person you are transacting with, and yet you know that your transactions will go and will be hassle free. So that's one advantage of using blockchain technology. Second advantage it talks about that is there is no central authority in between. So the alien in this video, when I'll share the link and you will watch it again, you will see he asks that you guys will be managing the chain. So it's not like that. In blockchain, the chain is managed by each and every participant, which happens to be the node of the chain. So the entire system is decentralized. So the power doesn't reign into one central authority like a bank or a system which approves the transaction. The approval comes from each and everyone who is a part of the network. So there is a consensus algorithm, and we'll talk about it in detail later in the class. But right now, that's what they discuss in the video. All the things which we could get away with if we are using the blockchain. So let's go into the details of the session, and I'll go ahead and discuss the details one by one. All the points which are mentioned in the videos and few more I'll be discussing in detail. Okay, and I'll share the link of the video in the chat later on so that you can watch it later. Okay, so apart from here is the analogy of using the Monopoly game. So some of you might have played this game in which you have these fake currency notes, and you throw a dice and then you buy properties and you buy lands, and whatever you buy is yours, and then you can sell it for some other price to the other vendor. So a lot of transactions happen in this game. How it is different from our daily transaction is, when we transact, we in real life we do not do it like the Monopoly game. So when we transact, we use a medium of transaction. If it's a regular currency, unlike the Monopoly, a currency is issued by the government of some country. So let's say Indian government issues the Indian national rupee, the INR, or the US government issues the United States dollar, which happens to be a bill of certain value, and you can transact from it. The other modes of transaction could be your cards transaction, where a debit card is associated to your debit account or your let's say savings or current account, or a credit card may be associated to your credit account with some bank. And then there are intermediaries like Visa or MasterCard approving these numbers for international transaction. So, and there could be other things like your cash cards, your prepaid cards are there. So there are various modes of transaction. But in Monopoly, these nodes, they are not verified by a centralized authority. So the two people playing a game, they understand the value of these nodes, and those who are part of the game, they buy and sell using these nodes. So very similar is the game in blockchain. I would not say in game, but in blockchain, all the advantages of this Monopoly game can be executed in the blockchain. So you do not need to trust the money which you use. It does not belong to a country, and therefore it is not issued by the government of a country. So if you're transacting with a foreigner, you do not have to think about currency exchange fee. You also do not have to think about a transaction fee, which is often paid to a central authority validating the transaction, like a bank in this case. So you do not have to worry about that. Everything is managed by the system itself, and the system guarantees the validity of a transaction. So that's how a blockchain is. Now let's understand. It's very easy, and we have been doing that from quite some time, to understand a system where there is a central hub which let's say validates a transaction, which says that okay, the bank issues your passbook. So whatever are the transactions in the passbook, they tell you that okay, this was your balance, this is what you transacted, this is the new balance. So everyone agrees to what the bank has says, because that's the central authority, that's the final say in what transactions happened and which did not happen. But in a blockchain, there is no such central authority. The advantage is we do not pay a fee. The point to think about is, how do we validate? How do we know that someone has made a transaction, and what was the amount, and how could you ensure that everyone agrees to what someone is saying? Okay, so these are the things which will be discussed in the session. Now let's go to roles and behavior. So what kind of roles we need? I also mentioned smart contracts. So what kind of contracts are we talking about? How can we encode a business logic in the form of a smart contract as though it looks like a transaction to the system, and then it can be run upon a blockchain? What gets transferred? When I say I transfer money, I get something in return. So what is getting transferred? How do we identify players? How do we know that who is playing the game, or who is the beneficiary of some transaction, or who is the donor, who is the giver, and who is the taker? And how is trust established in the entire system? So these are the points which will be discussed. If any one of you has something to comment, or do you have some idea about it, you may please speak. This is the right time to talk about it. So if some of you know a few things about blockchain and can answer one of these questions, feel free to speak now. Anyone? Okay, no worries. I'll take you through it one by one. So as I was mentioning, that there could be the mode of transaction could be the currency of a particular country. So let's say United States, they have a $1 bill or a $20 bill. So this has a certain value, and that value is recognized by the government of United States. Okay. Now there could be these cards which are internationally recognized, but then again, if it's a debit card or a credit card, the balance in the card, the debit balance or the credit balance in the card, uh, the amount of that balance is in the denomination of the country from which this card is issued. So let's say if HDFC issues me a Visa credit card and they give me let's say 7 lakhs or 8 lakhs credit limit, so that is 8 lakhs INR, which is a credit limit given to me from HDFC Bank, and I can do a transaction within that. Or let's say if it's a debit card, and let's say I have 50,000 in my account, so that is a debit card issued by HDFC and it has INR in it. Now I can use this Visa or let's say Master or any of these players debit card or credit card to transact in some foreign denomination too. So I can go ahead and let's say do a transaction on Amazon.com and pay in USD. I can do that, but there is a currency conversion charged. So my card has my currency, which is like Indian National Rupee at the moment. But if I make a transaction on a site which takes USD, then that there is a equivalent fee in INR which is charged. Plus there is a conversion fee which changes my INR to USD. Plus there is a transaction fee for the player who is doing this conversion for us. So these are the three fees which appear on the bill. Plus there are some taxes. So again, the advantage is I can make transactions with currency notes. I cannot make transactions outside India or outside my home country. But when it comes to these cards, I can make international transactions, although I end up paying some fee for conversion and some fee for transactions. Now comes the Bitcoin. In Bitcoin, people who recognize this currency are people who are part of the game. So they are part of the blockchain. So now they either have a few Bitcoins with them. So they have purchased a few Bitcoins by, like, let's say, giving some USD and purchasing a Bitcoin, or they themselves form the nodes. So they themselves are a part of the blockchain itself. Now they recognize this currency, they own this currency, and there is a ledger, a public ledger. So everyone knows who owns how much of Bitcoin in the complete blockchain. And this known information, which is publicly available and uneditable, unless and until a new record goes in, and the record will be like a new transaction happens. So, and which will change the account balance for a person. At least for two parties, one person may go down, the other person balance may go up. So till that record is maintained in the public ledger, everything is uneditable, and even anything in the past is uneditable. So I can have new records, new transactions on, but rest of things cannot be edited. Now this is how Bitcoin operates. So the ledger or the account balances is not maintained by a central authority, but is maintained by the system. It is available publicly to each and everyone, where people do not know each other's identity. They do not know that whether it's Avinash's account or someone else's account, but they do know that with a unique hash code, this represents some account, and on this account, this is the balance, and everyone agrees to it. Everyone who's part of the chain who is validating that transaction agrees to it. So I do not pay a transaction fee. I do not pay a currency conversion fee. I straight away pay to the user from which whom I have to do some transaction with. Let's say I have to buy a t-shirt from someone and I can pay in Bitcoin to that person. So their Bitcoin balance goes up, mine comes down, and I get a t-shirt in return. So let's understand how this happens. So the first one was Bitcoin, became very, very popular. The paper came out in 2008 by the name of Satoshi Nakamoto, which we believe could be more than one person. We're not sure, but this is where a working code was there in the white paper, and it talked about how can a blockchain be made, and there was a working code which could be used to create a blockchain based on which Bitcoin was developed. The ideas were taken on previous papers around the same thing called proof of work, and then it solves the problem of centralization. Now what is the problem of centralization? The problem of centralization is I need a central authority, a central hub to validate a transaction. There has to be someone who ensures and who updates the balance sheets for everyone, from whose account money was deducted, from whose account money is going in. So there has to be a central authority in between which is doing all this job, and they charge for it. In usual scenario, we have these authorities, we call them banks. So there is no centralization required. Double spending is safe, so I do not pay a transaction fee to my bank for transacting in USD and then to a bank in US. So that double spending of paying a fee on over the transaction. First, I'm transacting for some amount, plus I pay a currency conversion and a transaction fee. So that double spending is reduced. Identity, I do not have to disclose. Everyone is known by the unique identity, which is their hash code. And then consensus. So everyone agrees to, or more than 50% agree to what a transaction is. That's what is the final word. So whatever is the consensus, and it would, so there is a, let's say, negligible probability that someone could do a fraud on a blockchain, because you cannot make more than 50% people, which could be like, we're talking about millions, to agree on that, where these people do not know each other. Okay, there's no special roles of merchant, so it's like a buyer and a seller and the blockchain. So there is no role of a merchant or an intermediary in between, and it allows user to use of direct payments. So protocol establishing the decentralized peer-to-peer network. We call it peer-to-peer because it's like I can talk to the next neighbor, and then the neighbor can talk to each other. So everyone can communicate with everyone else. So it's not a network where we have to, every communication has to go to a central authority, and from there the communication proceeds. The final ledger is a public transaction ledger, which is uneditable. The only editing is a new record could be added when a transaction is performed. There is a rule base for validating transaction, and that rule we'll be talking about, which is the mechanism for achieving consensus. So a rule for validating or approving a transaction, and economic systems that rewards participation. The entire system would be economical because we are not doing double spending, we are not paying all this fee, so it is economical, and also it should reward participation. So people who are a part of the blockchain, they are rewarded, and we call it mining, and I'll explain you what it is. Let's go next. So what is consensus? So consensus is what the majority says, and it is about the rules and about the history. History means past transactions, and rules means how do we validate that a transaction is valid or not. So there has to be consensus about this, and coins itself should be valuable. Okay, what are the nodes? So a node provides one, a node is like a one machine or a user. So I register for Bitcoin and I am a user, registered user. So if I am also doing mining for them, so I be a part of the chain. So my system with a unique IP with the user identification attached to it, so that complete thing is a node. So there has to be a routing algorithm, there has to be storing, so parts of the blockchain are stored in various nodes in a distributed fashion. There has to be some mining going on. Mining is a way of finding the complete hash of the transaction which happened, and I'll explain you what hash is, so do not get confused right now, but you can take it at a high level that it is a way for finally validating a transaction, that some transaction happened, and updating the ledgers. Okay, and then wallet management. Wallet management is about all the people who have Bitcoins and who are part of the blockchain, so their account balance has to be managed, so their wallets need to be updated. Let's say I did a transaction, so something gets subtracted, some uh, debit happens from my account, and the credit will go to the account who got the money. Okay, so there are nodes which are responsible for SPV, also known as simplified payment verification. These nodes only verify transactions. There are other nodes running some specialized protocols, some specialized rules which they are supposed to follow. The query DNS seeds the domain name server, which takes care of the finding out from where this transaction first started or who completed a validation first. So these kind of things, the query DNS seeds when they start. So they form the seed of the domain name, the IP from which it started, keeps a track of nodes coming and going. So let's say I join, I am a part of blockchain. Let's say for in this case, let's say Bitcoin blockchain as a miner. So I join, but I might not be online all the time. So I may come and I may go. So there has to be a node which keeps a track of all the nodes which are coming, which are apart and which are going. So as long as I am mining and I'm dedicating my resources to it, validating a transaction, I'm a part of that blockchain, but I do not have to be available all the time. So nodes, they keep coming and going, and there has to be a track of which node is online at a particular moment. Then there has to be a methodology to broadcast transaction. Let's say a transaction gets approved. So I transferred money to someone, my account got debited, someone else's account got credited. Now this entire transaction has to be updated on a public ledger, which we talked about. So this ledger is publicly available and that has to be broadcasted. Everyone needs to have the same figures. Okay, so everyone should be able to see that. Then there are full nodes which keep a track of the entire blockchain and can independently verify any transaction. Then there are nodes, the form of communication is in the form of plain text, support for connections and node authentication, and the blockchain should also have support for encryption. So I can encrypt the data, so frauds will not happen. I can encrypt a transaction in a form so that no one can decrypt it, or decrypting it is like next to impossible. So I will discuss it in slight detail. It's a one-way function, so use that function to generate a unique hash which preserves the encryption of a transaction. And finally, the most important node which we talked about, the simplified payment verification nodes. So these are the important nodes here. This is how things look like. You have this full node client, you have these mining pool, these people who together go ahead and try to mine or validate a transaction. They use their resources together. And then you can have solo miners, a person who is doing still the same thing, but they are not collectively mining or not finding parts of the chain or parts of the hash or the transaction, but they are mining the entire transaction themselves. Okay, and this is for wallet management. These are the edge routers. So that's how a complete chain looks like. So these orange ones, they take care of the protocols which must be followed. The red ones are the stratum protocol, and the green ones are for pool mining protocols who follow the mining of pools. So all these green nodes, worker nodes. Okay, so now understand what is a hashing function. Now what happens is, let's understand first what a function is. So a function is something which takes the input and spits out a output. The easiest function could be, let's say I define f of x as a function. So that means that the function takes a value of the input variable x and spits out the output. Let me define fx as x plus 5. So if I have defined fx as x plus 5 and I give an input of x as 2, fx will be 2 plus 5, which is 7. If I give an input 4, fx will be 4 plus 5, which is 9. If I give an input 15, it will be 15 plus 5, 20. Now, for every input, there will always be a unique output. No matter how many times I give the same input, I will always get the same output. It's not that once f3 is 8, the next time also f3 must be 8. That's the definition of a function. Okay, so although this function is a very simple function and it's not exactly a hashing function, we'll come to it. But for any function, it can take an input and spit out an output, and every time for the same input, the output should be same. Yes, but the second thing is, for two different inputs, I can have the same output. So for one input, let's say 3, every time I input 3, I should always get the same output. But what I'm saying is, there is possibility that if I input 3 and I input 30, I might get the same output. That's a possibility of a function. So two inputs can give one output, and one input must give all the time the same output. So it could be many to one, it could be one to one, but it cannot be one to many. So you cannot have many outputs for the same input. That is not possible for a function. That's a basic mathematical definition of function, and hashing function agrees to that definition. Let's take a simple function to understand this better. Let's say my fx is x squared. So if I give x as 3, the output would be 9. If I give x as minus 3, again the output would be 9, because it's a squaring function. So it can take two inputs and generate the same output. But it can never happen that for 3, the output could also be 9 and also be 19. That will not happen. It will always be 9. That's about a simple function. Now let's understand what gets into a hashing. So generating hash code could be as simple as, let's say, spitting out a alphanumeric sequence of characters, which could simply be, let's say, the hexadecimal equivalent of some string or some number. If you understand what is the hexadecimal, it's a encoding system. Like we have a decimal number system, it could be a hexadecimal system. Usually our memory addresses or a hard disk address is in the form of hexadecimal, but it could be simply that, but there is more complexity to it. So first understand, it could be a hexadecimal code, but that's one part. Secondly, a hashing function has to be a one-way function. So what is a one-way function? A one-way function is a function which takes the input, spits out output, so it has all the properties of a function, but seeing several inputs and output, it is not easy or it is nearly impossible to retrace the function. So if I say that fx for f3 is 9 and f minus 3 is 9, then you can understand that most probably my fx is x square. Okay, if I tell you f3 is 9, f minus 3 is 9, f4 is 16, f5 is 25, f minus 6 is 36. Seeing these input output pairs, you can understand that what I'm doing is fx is x square. So you can retrace the function, right? Or the other function which we talked about, fx is equal to x plus 5. So if I say f2 is 7, f3 is 8, f4 is 9, f10 is 15. So you know what I'm doing is x plus 5. And then you can retrace back and you can find out the fx, which is x plus 5. Now these are simple functions. But when it comes to a one-way function, that means the function is complex enough. So no matter how many inputs and outputs do you have, using these input output pairs, if you try to retrace what the original function is, it will take eternity. So it will take at least 500 years to do that using the best supercomputers available. So therefore we call it one-way function, because it can take an input and generate an output, but seeing this input output, we cannot retrace back and find out the function. So these are the three important points of a hashing function. It is a function, it has all the properties of a function, and it can generate some hex output, but it has to be a one-way function. So seeing the input, I'll get a alphanumeric output, but I cannot know what is the logic for generating that output. So I cannot decode the function seeing the input output pairs. So this is to avoid, this is for usually this is the case for any cryptography, anything where I need to encode something, the encoding scheme should be a one-way function. So we'll look at one of the one-way functions which is common. So now the first property of function, for too many inputs there could be one output. So for a lot of possible inputs I could have a smaller set of possible outputs. That's possible. Many to one is possible. Again, let's say the other important property of a hashing function is the output is always of a fixed length. So the length of the output, let me check if it is written there. Yes, input size to a fixed output size. So input is always mapped to a fixed output size. So no matter the length of the input could be, let's say 10 characters long or 100 characters long. Output has to be decided in advance. Let's say I use something where the output is 256 characters long. So it will always be 256 characters long. Even if the input is 1 character long, or the input is 100 characters long, or the input is 1000 characters long, the output will always be 256 characters long. So that's also a very important point. So let's look at this. Let's say I have a file called message.txt, and in that file I wrote, meet me tomorrow for dinner at Carpe Vino. Okay, so this is like cat is a command, usual command in Linux to read the file. So I read the file message.txt, and this is the message it has. And now I'm using this algorithm is SHASM256. This is one of the hashing algorithms which is very common for encryption schemes and also used in blockchain technologies. So if I use this to encode whatever written in this message.txt, so I call SHASM append256 message.txt file, I get this output 36F0, this long output till DFF. Okay, this is my output if I use this algorithm, and this is a hashing function which has generated a hash code for this input. Now let's look at few inputs and outputs, and let's understand it how a one-way function is different from a regular function which generates output using a logic. So let's say if I have a usual function, a hex dump function, what it does is for password it has generated some output 70, 61, 73, 77 till 08. Okay, and then I change the input slightly. Instead of password, the new input is password. So last D is changed to E. And if I examine my output, I can say that okay, P is for maybe 70 and then A is for 61. The only difference is in the D part and here the E part, and I see that okay, there is a 64 and a 65. That's the only difference. So the output sequence always ends at 0A, and I have P as 70, A as 61, and D is 64 and E is 65. So I can always encode the I can decode the logic, because this is not a one-way function. This is a simple function seeing the input and the output, and I see that the output has no difference except for where the input was different. Instead of D, it is a E. So I can kind of decode what is done in this function. But let's look at the Shasham output. So let's say I have given password and I want to encode it with Shasham 256. Now this is the encoding for password, and let's look at for password, and this is the encoding. Now if you look 6B3A55 and this is C78E8A, so this looks like this is just randomly generated, though there is a set sequence, but it is next to impossible to predict the technique used to generate this output, to generate this hash code. And if we use the best machines, it would take 100+ years to find out which function is used internally to generate this output. So that means it is not feasible to retrace the function, and therefore we end up calling it a one-way function. So this function can take input and generate outputs, but from input-output pairs we cannot understand the function. I hope this part is clear. Any questions here? Okay. If you have, you can unmute and speak in between too. That is completely fine. Okay. Now, next comes the mining. So we know that we have an algorithm which can, we have a hashing function which can do the encryption for us. Now, what is mining? So let's say if a transaction is performed using some algorithm like a Shasham 265, I can encrypt that. Now, mining is a race to find a hash of a block less than the current difficulty level. So what does this mean? So mining is in which a lot of people are trying to race. Race means they want to find this block before anyone else finds out. So I want to find the hash of a block. So a block which forms a chain is nothing but a code, could be a hex code or maybe something generated by Shasham, which is the block of the blockchain. So every transaction forms the block, and each block is connected together because I cannot edit it. So each of a block, when they are connected, any transaction, then the next transaction, then the third transaction. So each of the transactions are forming these blocks, and these blocks are tied up together in terms of when did the transaction occur, and therefore we call it a blockchain. Okay, so mining is a race to find the hash of block that is less than the current difficulty level. Now let's understand what is the difficulty level, the amount of time it would take. So this is a one-way function. You cannot understand what is used to encode that block. So your aim is to find out, and the only way you can find out is looking at all the permutations and validate a transaction. Now, if that validation happens, whoever does it first, that person wins the race, and we say that he has mined that transaction. And then the other people, they give a consensus to it before it is put on a public ledger. So the transaction is added to the public ledger, everyone validates it, and so consensus is when more than 50% validated. So let's say two people say that they have done this transaction first, so we'll look at the consensus, who is having more votes about they mined this transaction, and then the transaction is put into the ledger. Once it is put into ledger, it is broadcasted and everyone sees that transaction. So this way, I do not need a central party to validate the transaction. The system itself is built in a way so that the participants of the chain, they itself validate a transaction, and transaction forms a block of the blockchain. And that's how the blockchain progresses. It grows. Now, the difficulty level will keep on growing when there are more blocks in a blockchain. So more transaction happening, there are more blocks added, and that's how the difficulty level grows. So I have to find the hash of block which is less than the current difficulty level. So uh, so there is a time in which I can find out each and every block. There's a time frame to it because I know what hashes have been generated by now. We'll take an example and look into it. So we have to find out between those numbers what is the right hash for this sequence. So that's what miners try to do, and they look at all the permutations. You can do some guesses, but you cannot means in fact you do not have to do guesswork at such long numbers. So you have a generate number generators or sequence generators. You keep on checking which one goes with the block. That's how you mine it if you have to. Okay, but mining is not the only aim for blockchain. We'll discuss the main aim, which is the lecture is about doing smart contracts and all. But yes, you have to understand what mining is. Mining is about validating those transactions. So miners, they also dedicate resources to the system. Their aim is not just to find a transaction first, win this race and earn some money. So the system is working because they are a part of the system, and their resources, their CPUs and their memory and their hard disk is a part of the machinery which forms the blockchain. So they dedicate their resources into mining and therefore become a part of the system which validate anything happening in the system. Okay. Now the block is constructed to include a coin based transaction. So there is some kind of transaction. Let's say Bitcoin has a Bitcoin, Ethereum has a Ether in it. So there is uh, some part of or you also call it a fuel, some gas, so which you pay for a transaction to happen. So let's say I'm doing a transaction of certain ethers or certain bitcoins, then there is an amount of fee which I pay, which is used into maintaining this blockchain, but that is very small compared to our traditional transactions. Other transactions are assembled into a block, usually based upon fee. Now, how the assembling happens, let's say multiple transactions are happening. So a transaction which has a bigger fee attached to it, which means the value of the transaction is more, that would be given preference over the transactions whose value is less. Now, fees are a difference between inputs and outputs. Miner profits upon winning the round from Coinbase plus the fee. After all coins are mined, it will just be the transaction fees which will be left. So if all coins are mined, if all the hashes are collected, then it will just be the transaction fee. Payment to miners is not the point. Security and validation of the blockchain is the point. So these people who are acting as miners, whatever small payment is given to them, that is not the main point. This is just to lure the miners in so that they form the chain. But security and validation of the blockchain is the important point. Based on this, the complete blockchain works. Validating a transaction. So you could follow a sequence of steps. First thing, if there's a transaction, then you have to check the syntax, the data structure, let's say the size of the output. There should not be any empty inputs, transaction size in bytes, and that should be less than the maximum block size. So between certain range, you have to look for those transactions. Output value should be of a reasonable range. Outputs don't already exist elsewhere. So whatever transactions have performed, they have a sequence. So my output cannot be that sequence which is already generated. I already know it cannot be those sequences which is already generated, because every transaction is unique in itself. Now inputs are valid and greater than equal to output. Lock times are reasonable. What is the lock time? Does anyone know what is the lock time? Do we know what is the lock time? Okay. So let's understand what is a block time. What is a lock time? So when you do a transaction, let's say uh, you are using your card at some merchant's point of sale terminal. So on the POS, you use your card, he dips the card, punch in some PIN number and proceeds with the transaction. So once you punch in the PIN number, a transaction request is placed. So let's say you are purchasing something of, let's say 500 rupees, and you use your Visa card at the merchant outlet. Now this machine connects to the Visa server. The Visa server authenticates that the Visa number is a valid Visa number, and then also realizes that which bank the card belongs to. So your routing of the transaction happens to the bank. It goes to the bank security, where bank validates your balance, as in if it's a debit card, your account balance, debit balance is checked. If it's a credit card, how much credit you have left, that balance is verified. And then it also looks in the between also if there is any fraudulent activity going on. So if there is no fraud going on and you have sufficient balance, the transaction is given a yes. So your transaction is processed, it's verified. If not, then the transaction stops. So during this time, it takes 2 to 3 seconds usually. So this time is called a lock time. So at the time your account, that means your credit card account or debit card account, is locked. And during those 2-3 seconds, no other transactions will happen on that account. It's a write-only query. So either this transaction which you are doing, it will go through, or it will revert and the transaction will not happen. But under any scenario, when one such transaction is taking place, your credit or debit account, that account, there's a lock, the lock in the sense of a database lock is imposed. So no other editing could happen on the account. What kind of editing? Let's say you have one account and you have an add-on card on that account. So at some point of time, and let's say you made an add-on card for your wife or maybe your father. So at the same time, both of you using the primary card and the add-on card cannot do two transactions. If one transaction is happening, it will wait for that transaction to get complete. Even if you try to do the two transactions at the same time, let's say both of you use the same debit card, one primary and one the add-on, and you go to two different ATMs in two different cities and try to take out money. So both will not be able to take out money. While one will take out the money, the other will have to wait. A transaction is going on, a lock is imposed, and it will take a few seconds. Once the first transaction is over, whichever transaction the system accepts first, once it gets over, the next transaction will be proceeded. But during that time, there will be a lock. Whereas there are transactions like a read query kind of a transaction where you're checking account balance, there's no lock imposed there. And if you are checking account balance from a primary card and an add-on card at the same time, you'll be able to do that on the same time because there is no lock. So there has to be locking and unlocking scripts, and those scripts have to be safe so that no hacker hacks on those scripts and puts a lock or removes the lock. So those scripts have to be safe, standard, and there has to be a way to validate that. Then transaction references match to the block or pools. Also, if a transaction happens, so the reference number for that transaction should match to the block or pool where that transaction happened. Okay, so that we can backtrace it and find out that yes, it is a valid transaction. The details will be there. You can visit this website for further details on the same. And that's how the proof of work for this Bitcoin was submitted. 1 out of 16 hashes should begin with 0. Even distribution of outputs. Set a target for finding a hash less than. So let's say if you look at this number, 0x, just ignore it. It's telling me it's a hexadecimal. So let's say 10 power, and let's see how many zeros. Maybe let's assume there are 30 zeros here. So this is 10 power 30, and this will be 0 and then 10 power 29. So between 10 to the power 30 and 10 to the power 29, there will be 1 with 29 zeros. So we are looking at that 1 with 29 zeros, and those are the numbers feasible between that. So between this and this number, you would want to find out, and there's a huge set of possibilities. You would find out the right sequence where this new transactions could be a part of, and you want to find that out. Is that clear, class?
Can you just share that previous slide's link?
Sure. I will be sharing this presentation too. Okay, so this presentation will be shared with you. This is the link you're talking about. Do you want me to open it?
Will you share it to a mail?
Just yeah.
Yes, the
In
presentation
the chat,
will
okay,
be
that's
shared.
fine. Okay.
Yes. Okay. So I can also put it in the chat, and if you look at the screen, you can wait. There's a copy paste here, but don't worry. This presentation will be shared. Okay. So you would know, and the recorded video will also be there on the site. Is it okay? So you can go ahead and look into the details of how these transaction works, so that if you, because there are some complexities also. It's not that whatever I'm talking about, it is a piece of cake, but at the first level, when you try to understand the basics, you go with some abstractions in mind. So it's like you want to drive a car, you want to understand or to be able to use the blockchain technology. In order to drive a car, you might not need to know every detail of the engine of the car. You may not need to know that. Okay, you simply need to know how to drive a car, how to apply the brakes, how to change gears, use clutch appropriately, and how to use the steering wheel. That's all you need to know. So there are some abstractions which I'm not getting into, but and they are not important in order to just getting started with blockchain. Unless and until you are from the creator community where you're working on the engine of the blockchain, you need to know there are the finer details. But to start with, that's how what miners do. So they want to find a number, a hash between a lower and a upper range, and they want to find it. And then how they're finding it, using those permutations between those ranges, because they already know that something till this difficulty level has already been generated, and less than this final difficulty level, they want to find new transactions. So it's not that they are guessing into the world of infinity. So they have a set range. Between that, they have to find the hash, and with a consensus where everyone approves of that hash, the transaction is validated, and it is affixed, that is appended in the ledger. So final line is added. So ledger itself is uneditable, but when a transaction happens, it could be appended. Even if it's a wrong transaction, you cannot delete it from the ledger. You'll have to make another transaction to talk about what happened in that transaction. So nothing can be deleted from the ledger. And in a way, the system is designed so that no wrong transactions could happen. A transaction will always happen if it is correct, and so there's no possibility of a wrong transaction. It's just that you want to revert on what you said, and you can revert it with another transaction. So network difficulty. So as I said, if as and when the number of blocks keep adding on, the network difficulty increases. It gets more tougher and tougher. So in 2010, if you look at this Bitcoin blockchain, so the difficulty was, and this is in terms of units of time, so it is like 0.1 T or something, and right now it is like approximately 15 T. So that's the difficulty to mine new block for the blockchain, to find a new block for a new transaction which has happened. Total hash rate, and this rate is in tera hashes per second, and that also you can see it has increased exponentially from 0.1 million to something in 2018 started increasing exponentially, when also Bitcoin price reached a new high and everyone got to know about it. And right now it is close to 110 plus million per second. So these are the tera hashes per second. These many hashes are generated per second. You need, in a way, you need more and more complex systems to do the Bitcoin mining. And Bitcoin mining becomes very, very difficult when more blocks are added. So therefore, people are doing it in pools. They together try to mine one thing and then share the profits instead of singly trying to do it on their own, because there is a lesser chance. You need more processing power to mine. It takes more time and more processing power to mine right now. But mining is not the aim, and this session is not about to motivate you about what mining is and to start with mining. The session is about so that you understand what is mining in the context of blockchain, and what other things are there in the context of blockchain, how blockchain is applicable to day-to-day business use, and how can you put to use in your context. That is what the intent of the session is. So no one wants you to like pick up mining of Bitcoin or Ethereum or any of these things, but you should know how it is done and why it is done and what is the aim. And as we already talked about, the aim is not to get profits from the mining, but aim is to dedicate some resources, distributed resources, so that blockchain operates. And obviously those who give those resources, they are also paid very well, in the form of remunerations for their resource, and they form a part of the blockchain. They form a part of the chain. So hashes and blocks are stored part of their hard disk. Their cores and RAMs are utilized as long as they are available in the chain, and they can on and off, come and go. And some systems have to be there stable. So this is about total hash rate, and we get on to the next very popular blockchain after the Bitcoin, which is the Ethereum chain. Now, Ethereum is also, this blockchain is also similar to Bitcoin, but with a lot of improvements. So it is not just about transacting, but any business logic which can be put into the form of a transaction, and we'll look into it. So we call it, this brought about something called smart contract based open source public blockchain. And we'll understand the smart contract based, what does this mean? And Vitalik Buterin originally wanted to evolve the Bitcoin platform. So he proposed this to evolve the platform, but met with resistance, and he opened his own platform, Ethereum. The cryptocurrency here is called Ether, and transaction times are 10 to 15 seconds on this platform at the moment. Again, this is a decentralized virtual machine that stores data and executes smart contracts. So smart contracts are any business logic which can be put in the system in the form of a transaction. Okay, and we'll see how. The key component is this idea of a Turing complete blockchain. As a data structure, it works kind of the same way that Bitcoin works, except the difference is Ethereum has a built-in programming language. So once you explain the business logic to the chain, what you want, the aim is that the language would want to put it in the form of a transaction, and the blockchain would verify that transaction. Okay. So introducing Ethereum and Solidity. So this is blockchain programming for beginners. So this is about how to use Solidity as a programming language for Ethereum blockchains, and we'll be sharing some GitHub links also where there are small codes for this, and I'll be showing in this presentation too the links also and part of code also. But you'll have to work with this. You do not have to be a very efficient programmer. No one here needs to know Solidity as a programming language. Base idea of any programming language like Java or Python would help you get started with this. You do not have to code a lot of things there. You have to define your business logic, which can be put in the form of a transaction, and then it could be executed in your own, let's say, private Ethereum blockchain. Okay. So we'll see an example to understand it better. And the second important thing is gas. So on Ethereum, the gas is the concept of, let's say you want a transaction to happen. So what you pay as a transaction fee is called a gas. Okay. So which helps the miners, and also, I mean, that's the kind of fee which is a small fee for executing your contracts. And again, it is very simple, but there are lot of frameworks around it, around Ethereum. So there's one called Truffle, smart contracts made sweeter, so which is more easier. So you let's say you do not have to be an expert of Solidity programming, but you install Truffle. Now this framework, it spits out the code required. You just have to edit your if else block where you describe your business logic, and then that could be executed in the framework. That could be tested, compiled, and executed. So you do not have to write the entire code. You simply have to state your business logic in the appropriate field. So Truffle is very popular. Then you have Ganache, which would help you make your personal Ethereum blockchain. So Truffle is for making smart contracts, but you can use Ganache and form your own personal Ethereum blockchain, or you can use Truffle and be on Ethereum's blockchain. If you do not want, if you have some specific needs, let's say something you want for your colleagues within one organization, and you want a personal blockchain for that, you'll use Ganache for that, and also for experimentations. So let's say you want to play with it, understand how it is working. And all this trial, you don't have to pay anything. You just learn how it works. You can install both this Ganache and Truffle on your local machine, but we'll also show you how you can work on Microsoft Azure, where everything comes with the installation kit, and you can get started with it. Is like easier than this local, although both steps are there. I would encourage you to try on local and also on Azure both. Now comes Solidity, which is the basic language. So smart contracts, some business logic that runs on the network semi-autonomously, moving value and enforcing payment agreements between parties. So we'll look at the now, like any programming language, this one will also have state variables. There will be variables whose values could be modified depending on the current state of that variable. There will be function. function modifiers, so getter and setter functions, events, data structures, enumerators, the fixed types, and the mappings between various variables and their values. So there will be some mappings, and then and you'll have simple contracts stated. So let's say you want to talk about or make a simple storage contract. So you define that, let's say in this case this is uint, which is like unsigned int, and then you have one variable stored data, which is the state variable, and you use this variable to store some values in it. Okay. You together then you define a simple auction function, which is like raising a bid. So there is a function bid. So all these function bodies can be also be generated. This example is also available on our GitHub code and also available on the GitHub platform, on the Azure platform. So which will give you an insight of executing very small thing in the form of a smart contract, but it will help you understand how can you put anything into a business contract. And once you can do that, you can form it in the form of a small contract, a smart contract. Then you have to make these editings in the base function. You can change the name of the function, the minor editings, and your code gets working. So you can start playing with the blockchain then and there. So the only idea is that you can do this, which makes a system which is capable of validating a transaction. So you do not have to have a external verifier like a central authority to verify or validate a transaction. As long as there are few parties involved in a system and there are rules to reach consensus, you can start playing with the system, and the system forms your personal blockchain. Plus you understand the technology, that how this actual blockchain is working, although the users are many more, it is in millions and billions, but how it is working essentially. You have these function modifiers, and you have the various events which could happen. So this is like simply for this example, and you can always verify, means modify it depending on your use case. Event listeners, struct type. So let's say there's another example, contract ballot. So this is for voting, and you have a struct voter, and then you define some variables, wait and voted, and address delegate, and then another unsigned vote. And in this data structure, you have an enum state, so which is like created, logged, and inactive. So what you're doing is, in essence, what you're doing is you're creating a way to do the vote counting, which are the votes put in the ballot, by using the consensus algorithm without having an external person count the votes for you. The system itself is counting the votes, and a consensus is achieved depending on the participants of the system. So those who are voting are essentially doing the counting, if you get my point, because that's the essence of blockchain technology. And there could be many simple examples to show that. You can also do it with Truffle, which will provide some ease with the same simple storage contract. If for your existing projects on blockchain, if you want to move them to cloud and you want to migrate them, there are links how can you do that from one system to another, or from one system to cloud. Let me just take you to some examples first, which make these a little better understanding. We'll come back to this. Give me a sec. Let me just come to some straight away examples. Okay, so one comparison is the way, let's say your internet was a medium for information. So what internet did was that it made information available to everyone. Similarly, what blockchain is doing is it made value for everyone. So value was available. So there is no intermediary, no transactions, and those who want to play a role in the system themselves form the system and benefit from the system without having to pay anyone else in between, and therefore reduce the cost of the system. But there are multiple applications which can be built on blockchain, especially in this context of a smart contracts. I mean, especially on the Ethereum blockchain. So blockchain based apps and services that are disruptive, not only because they are secure in nature, but because of how economical they can be to operate at scale. So you can have a number of users being a part of the blockchain, and in a very economical way. So economy that blockchain enables is not merely in the movement of money. So it is not just about transferring money or doing transaction. It is the transfer of information and the effective allocation of resources that money has enabled in the human and corporate scale economy. So the allocation of resources, everything which money does and everything which can be put in the form of described in the form of transaction, like a simple vote counting, can be done using a blockchain. So blockchain benefits, if you look into it, they are direct and indirect cost savings, higher speed via reduced delays, transparency of the system, so because that's a public ledger, so everyone can see and everyone sees the same thing. Better privacy, so users may not be known to each other. That means in the video we talked about aliens, so we can deal with anyone without even knowing that person. We know that he's a user because he is identified by a unique hash, and whatever is the balance in everyone's account everyone can see, but no one has to know who is who. Okay, low risk, equitable access, efficiency of processing and reporting, higher profits and growth, because we are not so anyone involved in these transactions do not have to pay a middleman in between. The principles it is based on is network integrity, distributed power. So there is no centralized power. The power is distributed amongst the participants. The integrity of the network is maintained by achieving a consensus based on every participant. The value as incentive. So let's say if you are playing a role and you are a part of the system itself and your resources are being used, you are incentivized for that. Then the security layer and the privacy layer is there. Rights preservation and inclusion of all those who are up, let's say, who have something to do with that blockchain or who are a part of it. If they want, they also become, they can be a part of that chain, and they can also earn something for that. So let's check some ideas. Let's say if we look at general ideas, the escrow transactions, the bonded contract, so any contract between two parties, third party arbitration, multi-party signature transactions. So all these things can be handled with by putting them into a smart contract and then putting it on a blockchain. Or let's say public records, land and property titles, which land or which property belongs to whom. So that can be verified by consensus. Vehicle registrations, verified by consensus whose vehicle it is, or what is the license number, business license, marriage certificates, death certificates, everything can be verified by consensus. So by the system itself, we do not need a different marriage registrar or a registrar office for death or registrar office for any kind of business license. You do not need such intermediaries in between, a central party to verify that. If this is put on a blockchain, then those who are part of it themselves verify it for each other, if you get the point. Identification, driving license, ID cards, passports, voter registration. So if you look at it, it's the way we think. It's changing the paradigm in which we used to operate. That's what this technology is doing. It's bringing about a complete paradigm shift. Uh, Other examples from private records could be your various IOUs, loans, contracts, bets, signatures, will. So let's say a will is executed, then various people, how many of us recognize that will? So instead of a central party who says that, okay, it was signed in front of the court, instead of that, the people in the blockchain themselves form a consensus and they define, okay, it's a valid will. None of them know each other. There's no way that you could know more than 50% and ensure people in your favor, where we have billions without knowledge of each other who is part of the chain. So there is no way, I mean, for a big blockchain, there is no way that a distrust could happen or a fraud could happen there.
I have a
Now,
question there.
yes, please.
See, basically, I've seen in the past that like hackers are using for ransomware, right? For
Mhm.
this blockchain they have used and bitcoins, right? So how can we say that ultimately it is not becoming a platform for those kind of people?
Uh, the question is, do you mean that a person who uses your resources uh, fraudulently, they use your resources for their blockchain?
Not
That's
like
what you're
no
saying?
no 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 no. I'm not
Okay.
asking that.
Okay.
Like for example, that was a virus incident, right? And they were
Mhm.
asking for the ransom amount, and they used their blockchain account, right? And they asked the money in Bitcoin. That if you want to,
Mhm.
so they kind of hijack the system, and if you want your system
Okay.
back, then you pay this amount. Right, this kind of
Okay.
thing happened because they were not being identified. So we cannot identify those people, and we have to pay them, and everybody paid them. So that is what is becoming a platform for those kind of people.
Okay, you can say that okay, it's because the user identity is not required. Then blockchain is becoming a platform for criminals or for illegal activities. You can always say that, but there are good applications also. And also when it comes to a hacker, so a hacker could hack into, let's say, Facebook account or Oracle account, and uh, even then we cannot verify the identity. So what I'm saying is, let's say I get access of database of Facebook users, and by some chance, although I know it is protected and it is secured. But if I start blackmailing Facebook, and they have to pay me something to regain the access. So there is no way, and I can ask money in Bitcoin or anyways, right? So if I have, so it's not about for that part, you're correct that when we are paying money, where is the money going? But even before blockchain was there, these blackmailers and people who blackmail and they extort, ask for money, that was already there in the system. So there are other ways in which you can ask for money where you do not have to reveal your identity, or you can uh, put in a fake identity which you do not know. So that's a different topic. It is more about security of the blockchain. It is more about security of the distributed system. So you have to have the security intact depending on how important those transactions are. And if there is a chance that they are very, very important and people could hack them, so you have to ensure that the security is good around it, and that has to happen for anything, blockchain or not. When it comes to blockchain services being used by criminals, yes, it is. But even multiple banks in this world which are doing traditional payments, they are involved in money laundering and a lot of criminal activities. And we do hear HSBC and a lot of names which are on the market, that okay, so this bank was involved, this money was laundered, and this government, let's say, put a fine on that bank. So a lot of things happen even in the traditional system. So there has to be a way. So it's like a police is there, and then there are criminals who are trying to be smarter than the police, and the police tries to catch the criminals and become as smart as the criminals are, and it keeps on going. So it's a iterative loop. So it will happen with blockchain, and it does happen with other things. Blockchain has some advantages when we do not have to pay us to a central authority, but those disadvantages which are already there in the traditional system, as in criminals getting being a part of the system, are there in blockchain. It seems like that they will be more protected here, but then they are more protected in the traditional systems also, if they have to play with the system. If so, I understand what you mean to say is that they do not have to reveal their identity. But what about in the traditional systems where they have to reveal their identity, and they reveal a wrong identity? So if you think that in those terms, so it is not that it is only a platform for illegal activity. A lot of good work, especially when it comes to smart contracts and enabling this business logic. So a lot of work is going on the Ethereum platform. It is not just about money laundering or doing some illegal transactions and asking for bitcoins. When it comes to the Ethereum platform, it is more about enabling mobile applications, doing a lot of things in the form of contracts, which earlier needed, let's say, marriage registration needs a central authority. I do not need it if I put it on a blockchain. If you get my point, right? And there is no necessity for anyone to go ahead and, let's say, hack that blockchain, because what would be the advantage? They would not get any money out of it, right?
Yeah, I
So
totally agree with. Yeah, I totally agree with you that for non means monetary transactions, I'm completely okay because that is something which is really good because now I'm not depending on a particular centralized thing. But for monetary, I'm still not happy with. Yeah, because see, ultimately your identity
that's
is
true.
hidden. Yeah, correct, right? So in that case, we cannot trace that person anyhow. Yeah.
Okay, so anyway, see, the intent for this session is not to promote and make people start dealing in bitcoins and start dealing in ethereums and other things. The intent is to make you aware of the shift in technology. Okay, so yes, there are a lot of loopholes and there are a lot of things which need to be improved, both in the traditional system and in the blockchain technology, because this is a new technology. So there is a huge scope of improvement, and definitely improvements we see that path is being paved and improvements will come in due course of time. All I say is that we as let's say audience should be aware of what is going on and how it could benefit us in some way as of now. In the future, if it becomes more effective, it becomes more acceptable. Countries do not, let's say, countries promote it in a way that they understand that no, this is not just for criminal activities, and there is a way so that the government can exercise some kind of control over it without becoming a centralized party, without having to charge a transaction fee, but also keeping a knob on the criminals. So there has to be a way, there is a scope of improvement, which I completely agree, but that will come with due course of time. We are just discussing the technology and not the social aspect here, if that makes sense, right? Is that clear?
Yes, yes, thanks.
Yes, most welcome. So these are some of the ideas which I talked about. Let me just talk about. So I would do what we will do is we'll share the GitHub links, whatever is there in this and the presentation and the complete video. This can also be done over Azure blockchain. So what I was talking about is, so you can, if you have an account of Microsoft Azure, you need to have a simple Microsoft account. You make an account and then you go to Azure Blockchain Development Kit for Ethereum. This is just for Ethereum. And if you install this, you get these applications which you can customize. So in the Visual Studio framework, you can, let's say this contract, Hello Blockchain would be there. It is also there in our GitHub code, for which the link is there in this presentation. So you can have a Hello Blockchain, which simply starts with on Ethereum. How do you make a simple hello world program of blockchain? So you can define a very simple logic in the form of a smart contract, and the basic places where you define your if else condition of what you think is a contract, or what you think is finally assessing, let's say, counting of votes, or finally assessing that this marriage certificate is valid, or finally assessing any of the things which you want to assess using your smart contract. Okay, so when do you say that this contract is executed? Let's say two people are married, that's a contract that's executed. So how do you put a stamp and seal? That is, you include it into public ledger and it is visible to everyone, if you get my point, right? So how do you do these small things in the form of blockchain, and those who are part of that blockchain, let's say 10 dummies who are part of the blockchain, they all approve it. So there is so you play around with it. So see that how we can go about decentralizing things and still gain the advantage. So this code is also included on our GitHub link, and it is there on Azure platform. So you can try it, which will be slightly simpler than doing it on local. The only thing is you don't have to worry about a lot of installations. So on the local, you'll have to look into if you have Windows. There are some complications, although things are there in the GitHub account telling you what complications you might encounter. Linux, there are less complications, but on the cloud, on Azure, there are like nearly no complications. You just click on, it's more of a GUI interface. You click and it gets installed. So you can play with it, and you can have your Hello blockchains, you can have your existing blockchains migrated, and you can have this migrations code. All these are, and you can deploy them, let's say your personal blockchain. Let me check if so. What I would encourage is that work a little on the links which will be there in this, and the GitHub links which will be shared with you guys. Work a little with the code and see if you can play with it. If there is any questions, you can mention it on the chat, maybe below the video, or let the community answer that question for you. At times, if the question comes to me, I will also go ahead and answer that question for you. But you'll have to get your hands dirty a little to, so you got an idea about high level how blockchain is working, and the minimum effort without even getting into details of the engine. As I mentioned, how can you drive the car without knowing about the engine? So how can you make a small blockchain, a private blockchain? How can you develop a smart contract on an existing blockchain and make a business logic work without a central authority, where people in the blockchain can come and go, and those are the nodes, and they verify or validate a transaction. So these things you can experiment with. I think that would be sufficient till blocks 79. Beyond 80, there are other things, but let's say till slide 79, that is the expectation from a basic session, that you play around with this and you experiment. I would also request you to provide a feedback for this lecture in the feedback link as shared. And let me check if, oh yes, so as I mentioned on the survey link, you can provide a feedback for this lecture, and would encourage you to ask questions. Ask as many questions as you can after you play with it, after you use the links there. If you can ask some questions about uh, this is what you did, these are the pain areas you could not understand, so that we can cover it in the next. This is a basics workshop, but let's say an advanced level workshop, we can cover those points. Any more questions for me? Anyone? So do we have any other questions on the blockchain? Let me just also share the link here. Yes.
I don't know anything about blockchain, but I'm a fresher. Yeah, so just want to know, like, can it be deployed? Can it be used in websites as such? Can this
Can
technology
it be?
be used like websites for anything?
Okay. Okay, so you can use the technology. What do you mean when you say can it be used on websites? So wherever you can, you have a logic which can be put into the form of a smart contract, where you can uh, say that, okay, you have to stamp whether something happened or not, or whether a transaction is complete or not, or you can put it in the form of asset properties of a database.
Okay.
You understand the asset properties? Whenever you can put something into that form, that's a transaction which is completed. If you can do that, then I think that is what we are looking for when it comes to let's say executing a smart contract. If we can put that logic, yes, a smart contract can be executed.
So how will a
And
website blockchain
so
differ
let's say,
from
yes, please. How would a website?
with blockchain differ from other websites without using blockchain?
Okay,
What
so
will be
let's
the
say okay, let's say let's take a very simple example which we did. So let's say I have a website and there are users coming to my website, and my job is to find out how many users come during a day. Okay,
okay?
so I have a central server to my site. Now this server's job is to count the number of visitors, unique visitors, so unique IP address which has come to the website during a day, right? Now what I want is that I do not want to be an independent party who is doing that counting and who is like a central party who is doing the counting. But what I want is that, let's say, people who form the blockchain, who have a purpose for coming to the website, themselves count each other and recognize each other or do things together.
Okay.
So there is no central authority required. So the main intent, the main paradigm shift of a blockchain is that you do not need a central party who develops trust in various people who want to transact with each other. So right now what
Oh,
we have parties like banks, and let's say I have a account in ICICI recognizes me. You may have an account in HDFC knows you. I want to send some money to you. I send it to from my ICICI account. I transfer the money to HDFC. It goes to RBI, a central authority. Then it goes to HDFC, and from HDFC it goes to your account. That's how it happens. But
yeah.
let's say if you, me, and others, we are on a blockchain, everyone knows. You do not know me as you do not have any personal information about me. What you know is that I am a user, I have a unique hash, and everyone knows how much each person has. And it is not in the form of INR, but how much each person has in form of, let's say, bitcoins, or let's say in the form of ether, whatever is the currency we are using. Or we can have our own currency on our blockchain. We can call it, let's say, Avinash. So how much Avinash each one has. So once we know that information, that ledger is publicly shared. And when a new transaction happens, that ledger is updated. In fact, the update is only you can append the ledger. So you can just add the last transaction to the ledger. Whatever is the past transaction, you cannot change it. that's only readable. So you cannot edit it. Okay.
So basically, it
this
reduces the work of the of people. I mean, it takes
it
up
reduces.
the server takes up the work of the extra load of.
Yes, so double spending is reduced. So there is no double spending. There is no central authority required in between, which plays the role of verifying and validating things. So if there is no such authority, we do not have to pay a fee to this authority, which we do not realize, but it is a good amount of fee. The second thing
Oh.
is that these authorities are local. So let's say I have a HDFC or ICC bank which is recognized in India but not in US, right? Or not in Russia or not in Japan. So what do we have then? If I pay in INR, I have to transfer this money to Japanese yen or maybe US dollars.
Yeah.
So what do? I pay a transaction fee first, a currency conversion, and the transaction fee. Let's say here my bank is HDFC, so some fee to my bank, some fee for currency conversion between the two countries, some fee for the bank in US, right? So I avoid all these fees. I do not have to pay this, and the transaction is immediate. So I'm dealing with any party at any part of the world. Therefore, the video which did not work, but anyways, the video was talking about humans executing a contract with the aliens. So obviously, both parties do not trust each other. There is no intermediary in between. But as long as both parties agree to be on blockchain, the system itself will ensure that the transaction's validity is certain and that there cannot be frauds and everyone knows what has happened. So that's the shift which blockchain is bringing in. It's a very good question because this basic session is about understanding what actually blockchain is doing. It is not about, so if you understand, we all know what blockchain is, means we might have heard this name a lot. But what is the essence of blockchain? We want to talk about it today. That was the intent.
Okay. Thank you.
Most welcome.
Hi, this is Ramesh here. Can I
Hi,
ask a
Ramesh.
question? Yeah.
Yes, you
See,
may.
yeah. See, blockchain seems to be a ground-changing thing, right? I mean, how the governments or central authorities, which are already entrenched in the system, react to this. What is the benefit of
Yes.
for them?
There is loss. In a way, means there are central authorities, especially the banks and the governments, which do not prefer this. But whenever something new comes, I mean, human beings, they have a tendency to resist change. So if we are comfortable in our shoes and if there is a change, even though it is for good, we would resist it because that would not be the way we are used to. So yes, they do not see a benefit, but when it goes when you think a little longer, when you think long term, there are benefits. So they if we but there are, it's not like the technology is completely ready. It's not completely ready. The transaction times in traditional transactions is still, let's say, 2 to 3 seconds at most. I make a transaction using my card in any country in the globe, and within 2 3 seconds, this Visa and Master can validate my transaction. Either it is approved or declined. But within 2 to 3 seconds, everyone knows that I made this transaction. That is not the case with blockchain as of now. So financial transactions, the speed is the most important thing. If I'm trying to validate that transaction within a few seconds and there are a huge number of people using this blockchain, then the complexity increases as I talked about, and it's gone to 10 15 seconds and even more at times. So we are not yet there. uh, Maybe linking of blockchain and AI and maybe quantum computing, that's one way in which you can interlink these, and that's the new future where we are setting into. Okay, where we can also get that speed from quantum scaling and we get the benefit of blockchain. But right now, these new technologies are shaping the future and we are living in this future. We will be in the future with this. So we have to understand what is going on. So uh, I would say that it's not ready to be immediately accepted by all the parties, all the financial worlds. The technology is not yet ready to that extent, but it has made a very good progress. The concept is very good. There are no intermediaries in between. Yes, it is taking time, and there are a lot of people who are working on resolving that step by step. And there are a lot of applications where things doesn't have to be time bound. So there are transactions. Let's say we talked about counting of votes. We do not have to settle this within let's say 1 second or 2 seconds. We can take a little time to settle, as long as we know that there is no party in between, there is no central authority, there is no bias. So we can rule out the bias and everyone can trust because it is visible to. So it brings complete transparency. Or let's say we talked about marriage certificates or death certificates. We do not need authority in between. We do not need an office, a corporate in between, which validates things and which approves and generates certificate. Everyone knows who is married and who is not. Right? If you understand that, then this system, this way of thinking itself is a complete paradigm shift. And there are places where these smart contracts can be executed and where things doesn't have to be within a few seconds. So right now the technology is ready for that. Okay, and in days to come, if it is ready in the sense that it can be quicker than traditional systems, it will anyways replace the traditional systems. If something is really good, it will replace it, no matter how much resistance is there, but it will replace it. If you understand me, right? If let's say there is an electric car in the market, so these petroleum exporting countries, they will always register electric car, because then they will, what will they export, right? But right now, from past 10 years, there were no good electric cars. So the electric cars had their issues, and therefore the petrol cars were very, very popular, petrol or diesel cars. But with good electric cars coming in the market, and although their prices are high right now, if they are economical, they will replace the traditional cars. No matter how much resistance is there, the resistance will vanish if we start seeing the benefit immediately, right? So the technology is in a way to prosper in the future, and we are here to understand and see how it grows. I hope that answered your question. Yes.
Agreed. So right now, maybe the technology is not ready for the real-time transactions. Maybe,
Yes.
as you said,
Yes.
it's like transactions which can take a little more than the real time. It is quite useful, but I see a lot of
Yes.
resistance coming in, and it could be overcome. I see as we bring awareness to the people.
That's true. That's true.
Thank you.
Most welcome. So I believe this was a good session for each one of you, and feel free to ask questions, fill the survey.
Avinash, one
Yes.
question.
Yes.
So
Yes. Please.
first of all, like thanks for the very good session. It was
Mhm.
like pretty detailed and like very good for the beginner like me. So so based on your experience with the domain, what kind of job prospects you are expecting or seeing in the current market in terms of the profiles and job roles coming in?
In terms of
So
blockchain.
in terms of blockchain technologies, right? So
Yes.
yeah,
So
yeah. So what's
there's a
the rate?
huge requirement for blockchain developers, people who understand distributed systems. So blockchain goes into a distributed ledger. So it is very similar to, I'm not sure if you are aware, but if you have heard about this big data domain where things are
Yes, yes.
done on distributed systems. So big data is the need for blockchain. So everything is distributed, and all the transactions, all the databases, everything is distributed amongst various users. So if it's open source, distributed networks form the foundation for such blockchain settings. So distributed processing is one, and there are a lot of opportunities in this field, because the way data loads are growing, we are looking for distributed systems engineers, maybe people who can do analysis on distributed systems, developers who can work on distributed systems and develop certain apps which work very well in multi-threaded distributed platforms. So there are ample opportunities. Specific to blockchain, which is also based on distributed systems, there are a lot of companies who are working on Ethereum's these smart contracts or various mobile apps based on Ethereum, and many companies are using it because they are shedding the load. So let's say supply chain management. So in supply chain management, I want to file a form for procurement. I want to procure certain goods. I want to ensure that I receive those goods. I want my inventory to be uploaded. If I can put the system, I can do this setting in the form of a distributed ledger. And although it has, it would take certain time for people to adapt to it, but then I would not have to rely on the news from the market or from various suppliers that, okay, their stock is down, I have to place a request. It could be automated. The entire thing could be automated because the system itself keeps on validating what is the status, how much is the inventory, what is the forecast for the upcoming market, and how can I replenish my inventory. So I can do a lot of things. A lot of businesses can adapt it. Although this would take a little time, maybe a year or two, but there are already many projects which are undergoing, which are executing smart contracts and moving from their traditional systems, because this is too much economical, because I do not have a central authority. I do not even have to worry about a centralized database, especially if I have a users, then normal RDBMS anyways won't work. So this is the way to go.
Okay, thank you.
Welcome. Okay, I hope this was a good session for all of you. Please leave your feedback and ask more questions, and we'll see you in more advanced sessions soon. Thank you, everyone. Have a nice evening.
Thank you.
Thank you
Thank you.
for the amazing session. Thank you everyone
Thank
for
you.
attending.
Thank you.
We'll see you in another session.
Thank you.
Thank you, Avinash.
Thank you.
Thank you.
Cool, then we'll share the recording soon.